In each of the previous examples that we've solved, our solutions ended up being valid solutions. We didn't have any values that were outside the domain for those logarithmic statements. That's going to change in examples 10 and 11, and we'll see cases of where we have these extraneous solutions, or solutions that don't actually fit the domain of the original expressions. To start off in example 10, since the bases of our logarithms are the same, we'll set x squared minus 12 equal to x. Then we'll subtract x from both sides to get x squared minus x minus 12 is equal to 0. Factoring will give us x minus 4 times x plus 3. And then potential solutions of x equals 4 and negative 3. We need to check those values against each logarithmic statement. So first, x squared minus 12 has to be greater than 0. That means 4 squared minus 12 needs to be greater than 0. That'll check out because we'll get 16 minus 12, which is a positive result. And then we'll need to take negative 3 squared minus 12 to see if that's greater than 0. But in this case, we'll get positive 9 minus 12, which will actually end up being less than 0. So since that result is not greater than 0, that solution is outside the domain. We don't even need to check that value in the second logarithm. As soon as it fails one of the logs in the original expression, in the original equation, we know we can throw that out. Leaving us to just check that x has to be greater than 0, and our value of 4 is clearly greater than 0, so that checks out. Meaning in this case, even though we came up with two values, since one of them is outside the domain for one of those logarithmic expressions, x equals 4 is our only solution. In example 11, we have the same basis for our logs, so we can set these equal to each other to get x squared plus 35x equals negative 60 minus 4x squared. Adding both of those terms on the right-hand side over to the left-hand side will give us 5x squared plus 35x plus 60 is equal to 0. Factoring out our GCF of 5, we'll have 5 times x squared plus 7x plus 12 is equal to 0. And then factoring, we'll get 5 times x plus 4 times x plus 3 is equal to 0. This gives us x equals negative 4 and negative 3 as possible solutions. We'll check that x squared plus 35x is greater than 0 when we substitute in those values. That will give us negative 4 squared plus 35 times 4, so 35 times negative 4, which will be 16 minus 140. We're checking to see if that's greater than 0. It would clearly be negative, so that doesn't work out. We can cancel out negative 4 as a possible solution. And then we can try negative 3. So we'll take negative 3 squared plus 35 times negative 3 and check to see if that's greater than 0. This will give us 9 minus 105. That's clearly not greater than 0, so we throw out that solution as well. So our answer to this problem would be does not exist or no solution some statement like that tells us there is no value for x that would make this equation true. The only way to know that is to go through the full process, factor the expression, find those two values, and then check them in each of those original log expressions to see whether or not they're within the domain of those original expressions.